All right, so here are the list of strategies. As we go over example 1 and we do part A and part B, we're going to see that a very common strategy, your most basic strategy if you have no idea what to do, change things to sine and cos and see if you can get a single fraction on both sides. So these ones right here, this one and this one, that's going to be our basic strategy. Can we change things to sine and cos, and can we get a single fraction on both sides, and maybe that's going to help us. We're going to see that sometimes if we use other strategies like the Pythagorean identities, factoring or multiplying, that we can do things quicker, but a basic strategy is changing to sine and cos. So in example 1, we had these two proofs, and the first one was cotangent plus tangent equals cosecant secant. A is a really good one to use the strategy of changing to sine and cos. So in this example, on the right side, they changed secant to 1 over cos and cosecant to 1 over sine. The only thing I'd be worried about here is it kind of looks like you've got them opposite. Doesn't it kind of look like cosecant goes with this one and secant goes with this one? Which is just the flip. Fortunately, in this case, it doesn't matter the order that you would multiply them in, so you wouldn't lose a mark in this case, but it's good to always try and work things through so that your next line matches up with the line above in the same order as well. So that means on the right side we do have a single fraction. It's just 1 over cos times sine. On the left side, cotangent is cos over sine, tangent is sine over cos. So you had an option here. You could have changed everything to tan on the left-hand side, but because our right side is changed to sine and cos, it's a good idea to change our left side to sine and cos. So not only are we using this second one here, change trig functions to sine and cos, you are, in a sense, thinking about this strategy here too. Always be aware of your goal. What does the other side look like? If my one side is in sine and cos, then it makes sense to change my other side to sine and cos so that I'm dealing with the same thing. And so that's what this person did here. Now on the left side we don't have a single fraction, so we get a common denominator. We multiply this one by cos and cos, this one by sine and sine. To get our common denominator, we get cos squared plus sine squared over sine cos, and cos squared plus sine squared is 1. Perfect. So this proof is done. Here's another one of example A. Again, use the same strategy. Change things to sine and cos, and got a common denominator. And you see at this point, this person was done. There is an extra identity that they knew about, and they changed them further. You wouldn't need that. So for right now, I'm not going to worry about this part. It's just extra, but they were done right there, which is great. Again, it's exactly the same strategy as the first one, changing to sine and cos and getting a common denominator. One last one from part A. Again, sometimes it looks like you make mistakes along the way and erase things out, so it can get a little bit messy perhaps, but this one used that same strategy. Changing things to sine and cos, getting a common denominator, and then working things out. Perfect. Now, part B. Part B was harder. First of all, it's got cotangent cubed. That should be just scary right off the bat because it's got something cubed. And then we got cotangent cosecant squared minus cotangent on the other side. So the first strategy we're going to look at, again, this is just the right-hand side, so we imagine that, what's this? No, that's A. Imagine the line was right here, and you had cotangent cubed theta on the left-hand side. So here is the strategy of changing things to sine and cos. Cotangent is cos over sine. Cosecant squared would be 1 over sine squared. And cotangent again is cos over sine. We want to get a single fraction. Right now we're subtracting fractions. How do you subtract fractions? We need to get a common denominator. So On this side, you've got a denominator once it's multiplied out of sine cubed. On this side, you would have to multiply by sine squared and sine squared to get that sine cubed as well. And then you've got a common denominator. So we've got cos minus cos times sine squared over sine cubed. From this step to this step, person noticed that there was a cos in common on the top. So one of the strategies that is on our list of strategies, factor. If you can factor something, sometimes that's going to be helpful. So in this case, we had a common factor of cos. That got factored out. And once you factored that cos out, you realized 1 minus sine squared is equal to cos squared. So I mentioned the other day, for those identities, I think I mentioned the other day. No, I didn't mention anything. I was quiet the whole day. Okay. Well, you need to have them memorized. Or you need to have them mostly memorized. Because what's going to happen in the middle of the proof is things are going to appear like 1 minus sine squared. And you want it to be on your fingertips that you know that that's cos squared. The best way to have that on your fingertips is if you have your identities memorized. If you have them mostly memorized, what that means is you say, oh, sine squared. I know that I have sine squared plus cos squared equals 1 on my formula sheet. Maybe I can see how I could rearrange it by looking at my formula sheet. And then you'd say, oh yeah, 1 minus sine squared is cos squared. But if you don't have it memorized or mostly memorized, you might be stuck and not know what to do next. Once it's changed to cos squared times cos is cos cubed. And then we get cos cubed over sine cubed, which is cotangent cubed. And this matches with the left side. So we're done. Perfect. So in this one, changing to sine and cos, getting a single fraction, worked out just fine. Now I'm going to show you another proof which makes it a lot quicker. So we could do this proof a lot quicker by saying, hey, this side's in cotangent, and if I'm aware of my other side, maybe there's a way that I could change this side to cotangent. And we have a relationship over here that cotangent squared plus 1 is equal to cosecant squared. So what this person did is they said, here I have a cosecant squared, and that's equal to cotangent squared plus 1. So they just substituted that in. Once they substituted that in, this gets distributed. You get cotangent cubed plus cotangent minus cotangent, and you're just left with cotangent cubed. And that is a lot quicker than the changing to sine and cos. But you had to be aware that, first of all, there was a formula with cosecant squared and cotangent. You had to know that both sides could be changed to all cotangent, and then you see that quicker strategy. But both strategies are perfect and fine. And you'll find that in an exam or a test, you'll often go to changing to sine and cos because it's what you're comfortable with. What I would do is while you're doing your proofs, maybe you do the sine and cos proof first, and then after you're done, you say to yourself, that took a long time. I wonder if there's a shorter way. Or I wonder if there's a different way that I could prove this that would go even faster. Okay, I'm going to give you another one, part C. Here we go. There's no C on there. This is what I want you to prove. Tan to the 4, yeah, there's more paper. You can come grab some off the stool here. Tan to the 4 minus secant to the 4 equals negative tan squared minus secant squared. So if we were trying to use the sine and cos strategy on this one and get a single fraction, most of you should have probably got up to here. So we notice on the left side that we could change tan to sine over cos. So it'll be sine to the 4 over cos to the 4. And secant to 1 over cos to the 4. And we could get a single fraction on the left side. And then on the right side, if we change to sine and cos, we could get a single fraction as well. What I like about this one, it's not done yet, but what I like about this one is this person is starting and did a strategy that we listed that we haven't talked about yet. Okay? The strategy that this person is using, I call build the other side. So it's the very last one on our list. And what it is when you're getting stuck and things aren't the same, you multiply to make them look more the same. So what they're doing here is they noticed, hey, there's a cos to the 4 on the bottom on this side. And once I got things as a single fraction on this side, I had a cos squared. How would I get a cos to the 4? I would need to multiply by another cos squared. And so they multiplied by 1 here. Cos squared over cos squared is multiplying by 1. It's not going to change what that equals to, but they're going to build the right side so they have at least the same denominator as the other side. And that is a strategy that usually can work really, really well. Now, before we go on further, I'm going to go back and I'm going to show you on this one another thing, another strategy that we had listed. We talked about factoring already, but I had in brackets difference of squares. If you recognize there's a difference of squares, it can often make your proof a lot easier. And on the left-hand side, tan to the 4 minus secant to the 4 is a difference of squares, and you can factor it. If you factor it, you're going to get tan squared and tan squared, one's plus, one's minus, secant squared, and secant squared. The nice thing about factoring it is we have a relationship between tan squared and secant squared. On our formula sheet, we have that tan squared plus 1 is equal to secant squared. So I want you to look at that tan squared plus 1 equals secant squared and do a little bit of rearranging. Can you ever rearrange that so you get tan squared plus secant squared? Can you ever rearrange that so you get tan squared minus secant squared? Can you get both, or can you get just one of those? Just one. Can you see that you'll never get tan squared plus secant squared? Because if you try to move the secant squared over, it's going to be negative. If you try to move the tan squared over, one of them is going to be negative. But we could get tan squared minus secant squared. How could I get that? I could get that by subtracting secant squared, right? But then I'd also have to move the 1 over. So what is tan squared minus secant squared equal to? It's equal to negative 1. So then we'd have tan squared theta plus secant squared theta times by negative 1. If you distribute that negative 1, and all of a sudden we're done. Left side is equal to right side, QED. Perfect. Okay? With this one, if you change to sine and cos, and you try to build up the other side, it would have worked as well. Some of the things that this person could have done now is being aware of the other side after they've built the bottom to be the same. Could change this cos squared to 1 minus sine squared. Need to have brackets here because we still need to multiply. A couple of other things. This minus sign somehow disappeared along the way. So there's a few little things that could cause us problems, but this was well on the way to getting it to work. But if you could see that difference of squares right away, it does make things go a lot quicker.